The operationalization of zero trust largely depends on how closely integrated an organization's network and security operations teams are. A seamless and cooperative relationship between these teams is pivotal in executing a successful zero trust strategy. Centralized buy-in across both teams creates a unified approach, facilitating a smoother journey towards a zero trust architecture. This holistic view is essential in tackling the multifaceted challenges that arise during the zero trust implementation process.
In the context of zero trust cybersecurity, the concept of segmentation across team alignment is pivotal. This approach integrates various facets of an organization, such as applications, operations, network, and security, to holistically manage and mitigate risks. Zero trust is not merely a technological implementation, but a strategic approach that necessitates cohesive effort across different segments of an organization. Central to this strategy is the elimination of silos within an organization. Traditionally, each department might operate independently, which can lead to inefficiencies and a higher security risk. The zero trust model encourages a culture of collaboration, where security, network operations, and risk management converge. This integration ensures that the security policies are robust, adaptable, and uniformly applied across all departments, enhancing the organization's overall security posture. The alignment of these teams allows for a more dynamic response to threats and changes within the IT environment. Any modifications in the network, such as the introduction of new devices or services, prompt a re-evaluation of security policies, ensuring they are consistently effective. This unified approach not only simplifies management, but also fortifies the organization against internal and external threats, yielding a more resilient zero-trust architecture.
Segmenting deployment into groups such as early adopters, early majority, and late majority provides better insight into the varying levels of readiness and acceptance within the organization. This categorization helps identify potential obstacles and necessary buy-in criteria required to navigate the zero trust journey. By recognizing these group dynamics, organizations can develop tailored strategies to address specific challenges and facilitate smoother transitions through each phase of implementation.
In the technology adoption lifecycle, we begin with the innovators, a small group known for their willingness to take risks on new technology. They are followed by early adopters who recognize the potential benefits of new innovations and are crucial for driving broader acceptance. These two groups form what is known as the early market. The chasm separates the early market from the mainstream market and represents a significant shift in adoption. It is here that marketing strategies must shift to appeal not only to those who seek new technologies, but also to those who are more skeptical and require established reliability and cost-effectiveness. Once past the chasm, we find the early majority. These individuals adopt new technology before the average person, but need to see practical benefits and the reduction of initial risks seen in earlier phases. They are instrumental in influencing the next segment, the late majority, which adopts an innovation once it has become an established standard and appears less risky. Finally, the laggards are the last to adopt an innovation. They typically have an aversion to change and will only adopt new technology when it becomes necessary or overwhelmingly obvious. This cycle not only helps in understanding different consumer psychologies, but also aids businesses in strategizing their marketing and development efforts to ensure a smooth transition from one group to the next, crucially bridging the chasm to reach a wider audience.
Successful zero trust. Operationalization is not limited merely to new technology. It must also encompass the onboarding of new entities and support staff. Without adequately trained personnel to support and maintain the technology, organizations risk compromising business continuity. Ensuring new staff can proficiently manage zero trust operations is critical for maintaining steady business functions and supporting the organization's broader strategic goals.
In transitioning to a zero trust infrastructure, organizations must methodically segment their networks to manage and secure access precisely. A manufacturing segmentation plan, such as the one illustrated, organizes the network into various business and operation sectors, optimized for a zero-trust approach. This structured segmentation allows for stringent control over who accesses what information based on strict identity verification and context-aware security policies. The segmented plan identifies different network zones, including office buildings, smart manufacturing sites, and data centers. Each zone is further categorized to tailor specific access controls and security measures suitable to its unique risk profile and operation needs. For example, business services and IoT in office buildings require distinct access management compared to line operations in manufacturing sites, where resource access needs streamlined control for efficiency and security. Moreover, cross-boundary access, such as corporate WAN and internet access, is managed to ensure secure connectivity while maintaining functionality across corporate and operational landscapes. Such segmentation not only enhances security, but also aligns with Zero Trust's principle of minimal trust, ensuring that access is granted only when absolutely necessary and based on verified criteria, thereby optimizing the network's performance and security posture in complex organizational environments. This approach improves governance over resource attribution and trustworthiness assessment across an enterprise, addressing crucial zero-trust architecture components.
One of the most significant ongoing challenges organizations face in their zero-trust journey is the maintenance of the zero-trust components and best practices. Maintaining effective mechanisms for discovery, asset management, and policy formulation is crucial to the lasting success of a zero-trust model. Consistent updates and refinements to security policies are necessary to ensure they remain effective, enabling organizations to adapt to new threats and operational changes.
In the landscape of zero-trust operations, maintaining robust policy enforcement is crucial for securing network architectures, evident in the layout presented for a Cisco network. At the very core, the utilization of policy administrators, PAs, and policy enforcers, PEs, across different domains of the network highlights a structured approach to cybersecurity. Starting with the local area network, LAN, the integration of Identity Services Engine, ISE, and DNA Center orchestrates user and device authentication and authorization through SDA Fabric deployments. This sector employs Security Group Tag, SGT, based segmentation, where access interfaces act as policy enforcement points, PEPs, summarily controlling access based on clear, predefined security policies. In the wider scope, at the corporate WAN edge, the configuration shifts to utilizing vManage and VSMART, coupled with vBond for broader policy enforcement and network traffic management. Evaluating attributes such as VXLAN tags allows for dynamic responses to network traffic, ensuring that only verified and authorized entities can interact or transact across the network segments. Transitioning to the data center's operational dynamics, the APIC controller takes precedence, managing the application-centric infrastructure, ACI, which again serves as both PA and PE. Within this environment, policies are rigorously implemented through virtual routing and forwarding, VRFs, tenants, and endpoint groups, which control the data flow between secured contracts, effectively encapsulating and isolating network traffic to protect against internal and external threats. Throughout this network, various nodes, whether they are devices, applications, or user identities, are continuously validated and their access managed via a centralized policy dictated by dashboard developers and StealthWatch integrations. This ensures a seamless, secure, and manageable orchestration of network policies, crucial for maintaining a zero-trust environment that adapts to threats dynamically while supporting legitimate network communication and operations. In conclusion, the rigor in policy maintenance across different network segments is designed to ensure that every component operates under strict governance to prevent unauthorized access and potential breaches, thereby fortifying the network's integrity and the organization's security posture.
Designing a robust attribution schema is essential for maintaining contextual identities within an organization's zero-trust framework. Understanding the implications of changes related to these identities allows organizations to assess their impact on operations, support, and the overall zero-trust journey. This comprehensive approach enables continuous monitoring and facilitates adaptive policy management in response to operational shifts and emerging security threats. Implementing zero-trust segmentation within an organization's ecosystem involves several critical considerations, notably policy changes and management processes. Effective management and modification of existing implementations require consensus among product owners and other stakeholders. Ensuring a transparent and cooperative approach to process modifications is key to sustaining the efficiency and effectiveness of zero-trust operations. Once zero-trust is implemented, maintaining its effectiveness relies on continuous monitoring and logging of network traffic and assets. Policy evaluations should consider monitoring data alongside inputs from stakeholders and external standards or threat intelligence sources. Feedback mechanisms involving resource users and organizational stakeholders are essential to refining and enhancing security policies, ensuring they remain aligned with organizational goals and evolving security needs. Successfully navigating an organization's transition to a zero-trust framework involves overcoming internal barriers and promoting cross-departmental collaboration. Leadership and sponsorship are critical in eliminating silos and ensuring that security and network team projects receive adequate resources and attention. Addressing potential adoption barriers through strategic leadership and fostering an environment of openness and cooperation is essential to progress the zero-trust agenda. The adoption of zero-trust principles follows a predictable life cycle akin to any major technology initiative. Innovators and early adopters pave the way, followed by the early and late majorities, and finally, the laggards. Each group presents unique challenges, from securing initial sponsorship to addressing the skepticism of later adopters. Understanding these phases and proactively addressing concerns at each stage is crucial for ensuring smooth organization-wide adoption of zero-trust. Application and operations teams are integral to the successful deployment of a zero-trust architecture. Engagement with these groups ensures systems are maintained without interrupting business operations. Application owners must work collaboratively to ensure that new implementations align with existing processes and operational requirements. Including operations and help desk teams early on facilitates smoother transitions and reduces the risk of disruptions. Maintaining a well-functioning support structure for zero-trust activities